In section 1.4, part 4, we're going to continue working with some substitution problems that are equations that are quadratic in form. We're going to do the uglier ones. The first ones made perfect sense because we see that the middle exponent was half of the first exponent. This one, example 8, we have x to the negative 2 minus x to the negative 1 minus 6 is equal to 0. So again, I noticed that I've got a negative 1 here, which sure enough is half of the negative 2. So it's another substitution problem. We'll come in and we'll let u equal x to the negative 1. By default, this is going to be u squared. Notice I'm not even going to write it this time because I know it works. So this would be u squared minus u minus 6 is equal to 0. A quick factoring, factors of 6 that subtract to 1 or 3 to 2. So we'll have u with a 3, we'll have u with a 2. Bigger number is going to take the negative to force the negative 1. The other one will have to be a positive. We can solve those guys. U equals 3, u equals negative 2. So it should occur or happen that once you've done that substitution, the next factoring step should be a fairly quick and painless one. We've solved it. Now we're going to unsubstitute. So we have x to the negative 1 is equal to 3. We have x to the negative 1 is equal to negative 2. Okay, so far so good. But what the heck does x to the negative 1 mean? So I'm going to remind you that x to the negative n power is the same thing as 1 over x to the n power. So that negative exponent means you move it to the denominator. So that means that this is the same as 1 over x is equal to 3. And this is 1 over x is equal to negative 2. So I took the negative 1 exponent, moving it to the denominator makes it a positive exponent of 1. We never write a positive 1 as an exponent. Well, now we need to solve this. You can do this a couple of different ways. I'm going to cross multiply this because I think that's the quickest way to think about it. So 1 times 1 is equal to 1. 3 times x is equal to 3x. So then x is equal to 1/3. If I do the same thing over here, I get 1 is equal to negative 2x, and x is equal to a negative 1/2. So we get two solutions, a 1/3 and a negative 1/2. Because there are no radicals, we really don't need to worry about checking them. You could, but we're not going to. Notice that we started off here and here, and really all that happened is we flipped it, right? So this was 1 over x equals 3. So then 1 over 3 equals x. So at some point you might be able to make that jump and not have to do all the in-between steps. And there's one with negative exponents. Let's try one with fractional exponents and see what that does for us. So this is example 9. Example 9, we have 3x to the 1/2 plus 5x to the 1/4 plus 2 is equal to 0. So I look at that, and before you freak out, let's notice that the middle exponent is 1/4. That is, yes, indeed, half of 1/2. So it's a substitution problem. We're going to come in and we're going to let u equal x to the 1/4. And by default, u squared is going to be x to the 1/4 squared, right? So 1/4 times 2 would be x to the 2/4, which sure enough is x to the 1/2. And again, if this confuses you, I wouldn't even worry about it. Just recognize that these are canned, they're designed to work. By default, this is going to be a u squared. So we have 3u squared plus 5u plus 2 is equal to 0. That does factor. Ooh, that does not factor. What am I saying? That does not factor. Factors of 6 that I divide. Oh, it does factor. Sorry about that. Every once in a while. So I'm going to have 3u plus 2 and u plus 1. Let's double check to make sure I factored correctly. This will give me a 3u. This will give me a 2u, which adds to the 5u. So u equals a negative 2/3 and u equals a negative 1. Now we're going to unsubstitute. If it didn't factor, you just use the quadratic formula. So it's not the end of the world if it doesn't factor. Use the quadratic formula, but we factored it. So we're going to unsubstitute. This time we're replacing it with x to the 1/4. So x to the 1/4 equals a negative 2/3, and x to the 1/4 is equal to negative 1. But we need to reinterpret this. That 1/4, if you remember from the first part, is a 4th root of x. That's equal to negative 2/3. Now I haven't done anything to solve it. I've just translated it. Well, this is saying the fourth root of something is equal to a negative. That doesn't work. So this one's a no solution. This does not work. I can't take the fourth root and end up with a negative answer. I have the same problems over here. Fourth root of x is equal to -1. The fourth root can't equal a negative number. So this is also no solution. So over together, there's nothing that's going to work. So this has no solution. The process is fine. It's just when we got down to the end, we could not simplify that. So okay, we have one more that involves substitution. So let's walk through it fairly quickly. This is example 10. You'll notice that this section has a lot of different kinds in it. So this one says we have the quantity 3x plus 4 squared minus 6 times the quantity 3x plus 4 plus 9 is equal to 0. Okay, looking at this doesn't immediately look like the substitution kinds of problems. We've got sets of parentheses, but what we are going to notice is that the sets of parentheses contain the same stuff. Sure enough, the second set of parentheses has an exponent of 1, which is half of the first set, or exponent of 2. So it's quadratic in form. So again, my clue is that those parentheses contain the same terms. So we're going to come in and we're going to let u equal what's the stuff in parentheses. So everything in parentheses, the 3x plus 4. If I do that, then I can replace the first one with u squared minus 6u plus 9, which then factors really easily into u minus 3 and u minus 3. Now, because they're the same factors, I really only need to walk one of them forward. Let's see that u is equal to 3. Then we'll unsubstitute. So now we're going to put the 3x plus 4 in place of that u. So 3x plus 4 is equal to 3. That's linear. There's no quadratic sitting there. There's no exponents of 2. So we can just move the 4 and then divide out the 3. So x is equal to a -1/3. And again, if I solve the other factor, I get the exact same one. So it's a repeated root of -1/3. Much easier than the fractional exponent one.